The following is a selected video from VideoMathTeacher.com, where you can explore over 10,000 videos, print out practice worksheets, find proofs and discussions on many math topics, and explore related videos. Try VideoMathTeacher.com today. Given parallelogram ABCD, let's prove that the opposite angles of a parallelogram are congruent, namely that angle A is congruent to angle C. To demonstrate this fact, we see that if we were to move point A in this parallelogram, that no matter what, angle A and angle C remain congruent. So, let's prove this fact in general. In general, to prove this fact, we'll use a two-column proof where we'll write down statements and their accompanying reasons. So our first line of our proof will be the fact of what we were given. We were given that we had parallelogram ABCD. Instead of writing the word parallelogram, we'll write the symbol parallelogram ABCD. And again, we were given this fact, so our reason will be that this was given. To prove this fact overall, we'll use a strategy. In order to prove two opposite angles are congruent, we'll divide our parallelogram into two triangles, and we'll show that these two triangles are congruent by the side-side-side congruence property, and from that, corresponding parts of congruent triangles will be congruent. So, the first stage will be that we should divide this parallelogram into two triangles. So we'll connect points D and points B together. So drawing our segment, we now have drawn this segment. So our statement will be construct segment BD. We can do this because 2 points determine a line. Determine a line. Next, from the fact that we have a parallelogram, opposite sides of a parallelogram are congruent. So, in particular, side AD will automatically be congruent to side BC. So, we'll record this fact as AD, this segment, is congruent to segment BC. As soon as we write this fact, we'll also label it in our diagram. So, since AD is congruent to BC, we'll use a single tick mark to represent that these two segments are congruent. While we're at it, segments AB and DC are congruent as well. So, AB is congruent to segment CD. Again, the reason why these segments are congruent, or true, is that opposite sides, which we'll abbreviate as OPP, sides of a parallelogram, which we'll abbreviate as the symbol parallelogram, opposite sides of a parallelogram are congruent. So AB is also congruent to DC, so we'll label this with two tick marks. We see that we're forming two triangles, and with these two triangles we already have two pairs of congruent sides. We can label the third pair of congruent sides, which would be for segment BD. In fact, BD will be congruent to itself. So we'll write down that BD is congruent to BD. The reason why is that any segment is congruent to itself by the reflexive property of equality. So reflexive property is what we'll label this as. And we'll label property just simply as prop. We now have two triangles in which three sides of one triangle are congruent to three sides of another. So therefore, these two triangles are congruent by the side-side-side congruence property. So our fifth reason we'll simply write as they are congruent by side-side-side. The two triangles are going to be triangles ABD is congruent to triangle CBD. Actually, CDB. So triangle CDB DB by the side-side-side congruence property. From this, now that we have two triangles that are congruent, then any corresponding part of one triangle is congruent to any corresponding part of another triangle. In particular, angle A must be congruent to angle C. So, angle A is congruent to angle C because corresponding parts of congruent triangles are congruent. We'll abbreviate this as CPCTC. Corresponding parts of congruent triangles are congruent. And so from this proof, we've been now able to prove that angle A is indeed congruent to angle C. So this completes the proof that we wish to show.